Hello and welcome to our final lesson in this unit. The last topic we're going to talk about is fuel consumption and vehicles. So at some point in the very near future, you will hopefully be getting your licenses, and maybe even sooner than you think, you might end up either owning or being responsible for a vehicle. So this is going to allow you the academic skills or the math skills to compare and talk about vehicles. So what's the learning goal? I can determine cost of fuel for a vehicle and compare vehicles based on their fuel efficiency. So it's that whole efficiency title or theme one more time here. So why is fuel consumption in vehicles important? Well, um, let's start with the poorer. So the poorer the fuel fuel consumption, the more fuel you use. The more fuel you will use. Oops, fuel you will use. So what does that mean? Well, the more fuel, the more fuel, the more money. So it all comes back to money. All right, and that's my whole point here, is to make this whole unit is to make you aware of how to save money. Okay? We want to save money. So we want to save money. All right. So it is a common theme. You would have noticed this now, because how many times have we talked about comparing appliances, electricity, water usage, so on, in order to save money? So moving along then, there will be a couple of formulas you will want to add to your sheet. So we have fuel costs. So this first triangle deals with fuel, distance, and mileage. So again, just a reminder that using the triangles, we use the horizontal line. We'll tell you when to do division. So that's our division line. And the vertical bar means you multiply. So distance and mileage, if you multiply them, you get fuel. If you do fuel divided by distance, you get mileage, and so on and so forth. Similarly, we have the cost and fuel price triangle. So again, you have division here. That vertical line is multiplication, and it allows you to calculate cost, fuel, and price. So these are the two triangles that we're going to be using in today's lesson. So the last thing I want to talk about is highway versus city driving. So with highway driving, for those that aren't familiar with this yet, and it'll be coming soon, highway driving, you get better mileage, or you get better efficiency. You get better efficiency. Now, why is that? Why do we get better efficiency with highway driving? All right, of course, I see hands up everywhere. You don't have to put your hands up, right? You're watching a video, not actually in class. So, a couple of things. You don't stop often. So, if you're on the highway, that means you are cruising at a constant speed. So, you don't have to stop very often. Another point is no, stop start, I guess, kind of is associated with that. So stopping and starting takes a lot of fuel. So stop, start is less. And finally, the car can cruise, I guess, which means that as it gets into sort of a natural rhythm, you find a comfortable speed, then the engine has to work less because the car is already in motion. All right, so the car can cruise. So we'll put quotations around that. We can talk about the physics of that when you take later science courses. With city driving, it has poor efficiency. All right, you're wasting a lot of gas with stopping and starting. So lots of stop start, lots of stop start. Oops, and what else? Lots of idling. So you're often sitting stationary for long periods of time. And speeding up uses a lot of fuel. So when you speed your car up, it requires a large amount of gas to move the car. So your city mileage is always lower than your highway mileage. So I got a couple of examples here just to finish things up, and I have the triangles already copied. So my first example, Darcy is planning to drive his 1982 Ford F-150 1,800 kilometers to his military base in Winnipeg. Current cost of fuel is $1.25. If the truck will get 18.6 liters per 100 kilometer, answer the following. So what we need to do here is we need to talk about, first of all, this Canadian notation for mileage. All right. So that's actually a fraction when we go to use our formula. So you need to be aware of that. So with A part, it wants us to calculate the amount of fuel. So we look at the fuel triangle. Here's the fuel. How do we get or calculate fuel? We multiply distance and mileage. So for A part, fuel or gas will equal distance multiplied by our mileage. All right, so the distance is given. It's 1,800 kilometers multiplied by that 18.6. We have to enter it in as 18.6 divided by 100 because it's, in Canada we always reference our fuel economy with respect to how many liters it'll take to go 100 kilometers. It's just the notation we've adapted. So as long as you remember that, it's straightforward from that point. You can take out your calculator. And using the calculator, we simply punch in 1800 multiplied by 18.6 divided by 100, and we end up with 334.8. So 334.8, so 334.8 liters. So therefore, Darcy will use 334.8 liters of gas. So he's got a little bit of a old beater truck here, and it's taking a lot of fuel to get out there. So B part, calculate the cost of fuel. Cost of fuel. So cost of fuel, we look at our chart. Here's cost from the triangle. So to calculate that, we need to multiply fuel times the price. So B part, cost equals fuel times the money value. So we just calculated Darcy will need 300.48 liters, and we're going to multiply that by $1.25 currently. So for him to drive his truck, we need to get our calculator out, and we take the 334.8, multiply that by $1.25, and his truck alone is going to take $418.50. So that was $418.50. So therefore, it will cost Darcy $418.50 to drive. So fairly pricey. All right. Now as we move on to our second example then, For some bizarre reason, Mr. Young, he's also going to go to Winnipeg, and his car gets 5.7 liters per 100 kilometers. So Mr. Young's a little more savvy in the vehicle he picked. He picked a little bit more fuel efficient one, and same distance. And we'll go ahead and we'll look at the calculations here. So for A, calculate the amount of fuel he'll need. So fuel is equal to our distance multiplied by mileage. So that would be 1800 again. 1800 kilometers multiplied by, this time it's 5.7 over 100. We go ahead and we calculate that. And we get 102, 102.60. Whoops, that's liters, that's not money. So 102.6 liters. So that's how many liters it took Mr. Young in his particular car. So B part, calculate the cost. So cost will equal fuel multiplied by the price. So 102.6 multiplied by $1.25, and you get your calculator out for that. And I get $128.25. So $128.25. So back here, therefore, he used 102.6 liters. And here, therefore, it cost 128.25. So C part then, how much more did it cost Darcy to drive? Well, Darcy, it cost him $418.50 to pay for the gas in his vehicle. Mr. Young only paid $128.25. So when you use your calculator to find that distance, we find that we end up with 418.5 minus 128.25, $290.25. So we end up with $290.25. So therefore it cost $290.25 more. So when you are selecting a vehicle in the future, the old vehicles are, I admit, very cool. A lot of them look pretty nice, but you need to remember the older the vehicle, the poorer the fuel mileage. And when you're the one that's putting the money in the tank, you need to keep that in mind because it is costing you money. So the bigger the engine, the older the vehicle, the less fuel efficient it is possibly to the newer vehicles. So with fuel mileage, you are looking for a smaller number in the Canadian system. So 18.6 versus when you look at the other one, 5.7. So when you're looking at liters and kilometers, the lower the number, the better. So keep that in mind. There's everything you need. That will allow you to finish up this unit. You'll have a bit of a car investigation to do for me, and then we'll have a brief assessment, and we can move on to the fourth unit in the course. Good luck.